The Hubble Space Telescope has shown us some amazing views of the universe. How will the Webb telescope improve on that?
Well, there's no doubt that the Hubble Space Telescope has completely revolutionized our understanding of the universe. But there are some things that Hubble just wasn't designed to do. So the Hubble is primarily an optical telescope. And one of the primary differences between Hubble and the James Webb Space Telescope is that Webb will see the universe in infrared light. And so by looking at the universe in infrared light, it will allow us to see back into the early universe, see some of the first stars and galaxies that formed. It will allow us to see down into the dusty clouds where stars are being born. So lots of different things that we'll be able to see with the Webb that Hubble can't quite see right now.
How will the Webb telescope see so far back in space and time?
Well, there are a few key differences between Hubble and Webb that are going to allow the Webb telescope to see further back into space and time. And again, one of the main differences is the fact that the Webb will see the universe in infrared light. Another thing is the Webb telescope is just very big. So to answer these big questions in science, we need a big telescope. And the Webb mirror will have about 7 times the light collecting area that Hubble will have. And so it will be able to collect more light and be able to see back further into space. Another thing is that the Webb telescope will be sitting out in deep space, out beyond the orbit of the moon.
Why will the Webb telescope have to face such harsh temperatures in space?
So because the Webb telescope is an infrared telescope, infrared light is basically heat radiation. And so the detectors, the cameras themselves have to remain very, very cold in order for the telescope to be able to detect these faint infrared signals from the distant universe. And one of the challenges to building a telescope like this is to build the telescope itself here on Earth in normal temperatures and then launch it into deep space. And so just to demonstrate this, here I have some surgical tubing, which you can see is very flexible, bendy, and normal temperatures here. But if I dip it down into liquid nitrogen, you're going to see how the structure of the material changes. And so when we build these telescopes here on Earth, we have to be really smart about what we build them with and how we build them, and have to do lots of tests to make sure they will withstand the cold of deep space. And so you see here how the material completely changes. The structure of it just completely changes when it gets very, very cold. And here at Goddard, we have undergone a crucial milestone, a test of the structural heart of the Webb telescope. This test has shown that it's going to withstand the cold of deep space.
What other mysteries of the universe are there still left to solve?
So we have lots of questions that we still want to answer, and the James Webb Space Telescope is going to allow us to start to answer some of these. One of the things is we hope to be able to see the very first stars and galaxies to light up in the early universe. We also hope to see galaxies forming and evolving over time. We plan to see down into dusty clouds where stars are being born. And also we hope to see down to the planetary atmospheres of exoplanets, be able to see some of the chemical signatures in those planets. So lots of exciting questions left to answer, and we hope that James Webb Space Telescope is going to be able to launch us into that next era of answering these big important science questions.
Where can we go to learn more about the Webb telescope?
To learn more about the Webb telescope, go to jwst.nasa.gov.